right, so this is lesson 2 in the Powers and Exponents unit of Math 9, and today we're looking at 3 exponent laws that can help us simplify and evaluate different mathematical expressions that have powers in them. Okay, so we're going to go through the 3 laws and then we're going to answer some questions. When we go through the 3 laws, I'm going to try and explain why they exist. So it's important to understand why they work and not just memorize them. Okay. So first one, this one is called the multiplying exponents with the same base law. It's law number 1. So let's look at an example. Let's say I had 4 to the power of 2 multiplied with 4 to the power of 3. So if I were to write those out, 4 to the power of 2 means 4 times 4. And 4 to the power of 3 means 4 times 4 times 4. And if I were to multiply all those 4s together, I could simply add them up and I would get 4 to the power of 5. So the law is essentially you add the exponents. When you're multiplying numbers with the same base, 2 plus 3 is 5. That's because the number of things that are being multiplied gets added up together. So we can show why it works with this other example here. 2 to the power of 2 times 2 to the power of 4. Let's write those out. So 2 to the power of 2 would be 2 times 2. 2 to the power of 4 would be 2 times 2 times 2 times 2, multiplying 4 2's. And if I look at how many 2's I have there, that's 6 2's altogether. So then it would be 2 to the power of 6. Okay, and 4 plus 2 is 6. So we can see why that law works. So we add the exponents when we're multiplying powers with the same base. Okay, so that's law number 1. Law number 2, it's about division. What happens when we divide powers that have the same base? So let's take this example, 4 to the power of 5 divided by 4 to the power of 3. Very important that the bases are the same. Let's write that out and how that would look. And we're going to write it like kind of in a fraction format. So 4 to the power of 5 is when we multiply 5 4's together. And 4 to the power of 3 is when we multiply 3 4's together. And if we write in a fraction, we can see that 3 of these 4's are going to cancel out, right? If you have the same number on the top and the bottom of a fraction, you can reduce it if you have multiplication. So I'm left with only 2 4's remaining. So essentially what I did here was I subtracted. And I'm left with only 4 2's. Let's show why it works with another example. You could pause the video here and do this on your own, or you can do it with me. Let's divide 5 to the power of 6 divided by 5 to the power of 3. Again, very important that the bases are the same. So 5 to the power of 6 would be 6 5's being multiplied together. Right? 1, 2, 3, 4, 5, 6. And 5 to the power of 3 would be 3 5's being multiplied together. 1, 2, 3. And we can see those cancel out and we're left with 5 to the power of 3. And we can see that 6 minus 3 equals 3 also. So the rule works. What we do is we subtract the powers because of this canceling out effect. Okay, so that's rule number 2. We subtract powers when we're dividing exponents with the same base. The last law, law number 3, is what happens when we have a power of a power. So we have, let's say, 4 to the power of 2, and then all of that is to the power of 3. So let's see how that looks if I were to write it out. The power of 3 means we're going to multiply it 3 times, and 4 to the power of 2 is 4 times 4. So essentially I have 3 groups of 2 4's. So I've got 6 4's altogether. So what we do is we multiply the exponents in this case. So when you have a power of a power, you multiply the exponents. Let's try it with this one. You can try this on your own if you want. We've got 10 to the power of 4, and that's all to the power of 2. So I'm going to have 2 groups being multiplied together. Inside here I'm going to have 4 10's. 2 groups of 4 10's. So that will give me 8 altogether. 10 to the 4 times 2, which is 10 to the 8. Right? We can see why that works. Okay, so when you have a power of another power, you want to multiply. So those are the three laws. You can review them again if you like. And now we're going to actually use the three laws. So we have some scenarios here. We have 6 different scenarios. First thing we want to do is analyze the problem and figure out what law to use. Then we're going to use it and answer the question. Okay, we need the laws to answer the questions here because a lot of these powers are really large and we wouldn't be able to really answer them. Even some calculators, they don't have a screen that's big enough to display these answers because they're such large numbers. So we need to use these laws to simplify these down first before we evaluate them. Okay, first one, we have 2 numbers here that are the same base and we are dividing them. So we want to use we're dividing. So we want to use law number 2, which means we want to subtract the 2 powers. So we're going to have negative 3 to the power of 17 minus 15, which is negative 3 to the power of 2. And the numerical value would be negative 3 times negative 3, which is positive 9. Okay, let's look at the next one. This is a power of a power law because I have a power here and then another power right away here. So the law says we're going to multiply those powers. So it's going to be negative 2 to the power of 9. And the negative sign, notice it's on the outside, so it's not affected or impacted by the law. And we're going to multiply 9 2's together. 2 times 2 times 2 times 2 times 2. It's negative 512. Okay. Next one, we are dividing here, so we're going to use law number 2, and we're going to subtract. So 11 minus 8 is 3. And now we're going to evaluate 5 times 5 times 5 is 125. I'm going to try the last 3 on your own if you want, or you can do them with me. Here we have a power of a power. So we're going to multiply. So we're using law number 3. And it's going to be 1 over 10 to the power of 8. And so that is 1 over, and then 1 with 8 zeros, 100 million. 1, 2, 3, 4, 5, 6, 7, 8. Okay, next one, we are multiplying this time. So we're going to use law number 1, and we're going to add those exponents together. So it becomes negative 4 to the power of 7. And if you multiply 7 4's together, the answer is negative 16,384. It's negative because we're multiplying an odd number of negative numbers. Okay, and this one, again, law number 1, we're multiplying. And we add the exponents. The 2 exponents are 3 and negative 3. So when we add those together, we get 0. And anything to the power of 0 we learned last lesson is equal to 1. Okay, so that's a quick overview of the exponent laws.